All right, so when you look at the investigation, it's to do with polynomials. So a polynomial is a function that can be written in the form, it's shown here in pretty small writing, p for polynomial if you like, p of x, so it's a function in terms of x, and the pattern that we write it in general is the leading coefficient is an a, and then every x term that has a power, you do it in order, you write it out so that the first term has the highest power. Can I have a tick? Do you understand that if it's a quartic, a power to 4, that you do ax to the power 4 plus bx to the power 3 plus cx to the power 2? All right, so that is the general form of a polynomial. And you can do it for any number. You can do it for ax to the 12. Then you're going to use 13 letters of the alphabet and go down A, B, C, D. All right, so that's the first thing. Now, polynomials can be written out so that they have that the factors show the roots. So I'll just go quickly to the whiteboard. And if I just draw a polynomial, all right, this is a pretty complicated one, then everywhere it cuts the x-axis, what can you tell me about the value of the polynomial y at the point A? First off, what is the value of y at the point A? Anyone know? Bianca, if you run out of letters, you start using the Roman numeral system, alpha, beta, delta. You make up some other symbols. Okay. All right. Abdurrahman thinks it's -2. Now he's made up a scale. Abdurrahman, can you see that if you made up a scale, that would actually be a equals -2, which is the x value? So can you build on that thought? If what is the y value at point A? And even if I agreed with you and I said, yes, the scale that you've suggested works well, we'll call that -2. It is 0. Others give me a tick. Do you agree that when a is -2, the function y is 0 because the root would be x take a. So if x is -2, if x is -2, -2 minus a is -2 plus 2, which is 0, and it doesn't matter what the rest of the factors are. That's it, Bianca. The rest of the factors, they can have any value you like. 0 times anything is 0. So we call it a null factor. All right, so the roots are where the polynomial equals 0. So the x-intercepts, A, B, C, and D, the value of the polynomial will be 0. So that's one reason that we write out the polynomial in factors. So we're going to investigate the polynomial. And they actually tell us that we can factorize it into 7 different forms. And I'm going to leave that because Andy does that really well on the recording. So if you can't open that recording, email me, and there's probably I think there's something you can download. I can forward it to you. All right, so we're going to investigate the polynomial, and to begin with, we're just going to look at polynomials of degree 4. So that means x to the power 4 is the highest power. And we're going to look at the number of turning points. So let's go back to my drawing. This is actually, I know, it's to the power 5. So I need to rub a little bit out if it'll let me. Rub out D. Oh, no, it wouldn't. So if I do 1 to the power 4, I'll try and go through my A's and B's again. All right. X squared. How many turning points in this diagram? So I'm going up and I turn, when it's 0, a maximum, a vertex, it turns down. 1, 2. All right? So that's, you have to be able to match the formula with the picture or with the graph. The next thing I'd love to do, and I'll possibly do a bit more of that in tomorrow's lesson, but I'll just quickly do it with you now. Have you ever used a graphing software called Desmos? So Desmos graphing. Yep. I recommend you can do this on your calculator, but actually the Desmos graphing is better. So while I open mine up, could you just Google search Desmos graphing and see if you can open one of your own? So just share my desktop. So first of all, that's a bit off the edge, I think. Now, I'm a little bit worried. I missed a phone call earlier. I'm hoping that they don't want to see me at 1:30. So I'm going to do a little bit more and then I'm going to stop because I've just remembered a commitment that I've forgotten about. But I'll do more later. So the graphing software, you're going to love it. If I write in y equals ax, and I'll do the cat button for the power. Now I want to do a quartic, so it's going to be power 4. And I'll just do the arrow across to the right to get the cursor flashing, not as a superscript, plus bx to the power 3, which is, so you can see I'm writing out the general formula of a polynomial, plus cx to the power 2. And oops, that's not what I wanted to do. Cx squared, I've just got to go across, plus dx plus e. Now, why hasn't it done it? Now, normally, when I'm not in a hurry, it gives me the option of doing sliders. Now, I didn't log in, so let me just, I'll hit save. Oh, it's logged in as me. Why? Subscripts cannot be empty. Oh, okay. So when I made that mistake, I've got to get backslash. There, now it's done it. So this is what I want you to see. A, B, C, D, and E polynomials, they're pronumerals, they're a letter to represent a number, and we want to be able to make a fixed number and we want to be able to change it. So if I say all, and it starts off with A is 1, if I change the value of 1, I can make up a whole stack of polynomials of any shape I will, and I could see how the shape changes. So that's a bit too large for the screen. So this isn't a particularly clear one. What if I make that there? That's a bit better. You can see on this shape one that it goes up to a maximum, down to a minimum, up to a maximum, and down again. So this is quartic because the highest power is 4, and it's got 3 turning points. Can I have a tick if you were able to see that? Yep, Bianca had to go. All right, so Abdurrahman, I would suggest that you guys, I've only given you a tiny little bit to get you started, but could you watch the recording from Andy and open up Desmos and have a play, and then ask another question, and I'll help you a bit more. All right, thank you very much, and my apologies because I did forget that I've got another commitment coming up pretty soon. See you, everyone.
Thank you, bye.
See ya.